good morning, everybody. So I'm Ryan Coleman. I'm a product manager at Puppet Labs. And please feel free to come to any of us if you want to have a conversation about anything we're doing. I'm one of the product people here, so you can talk to me about future direction. You can ask me any of the technical questions, anything that you don't get answered from anyone else. Feel free to come find me. So before we get started here, I want to give you a couple of shout outs to our sponsors that made this Puppet Camp possible to come and view these talks and eat and drink and talk to us. So Yelp, Cisco, and Proofpoint sponsored it, made it possible today. So if you see any reps from those companies, please thank them, buy them a drink later, or hand them a drink, I guess. And then, of course, Citrix for this awesome space. This is the second time I've presented in this space, and it's really one of the best I've ever presented in. So thank them a lot. Thank the guys in the back. And yeah, have a good time. Oh, and please mute your phones. Try to be respectful. If you have to take a call, just step out. I won't be offended. And as far as taking questions during the talk, if you have anything about the content, feel free to raise your hand or just interrupt me. I'm happy to take questions about what I'm talking about. Otherwise, I'll try to leave some time at the end for general questions. To start it off, I wanted to get a sense of who you are and who I'm addressing here. So it looks like almost all of you are new to at least this Puppet Camp, which is pretty cool. How many of you are using Puppet right now? OK. So I'm guessing about a half of you. So that means the other half are about new. So I'm curious, in terms of those of you using Puppet today, is anyone running Puppet 4 in production? You are? No Puppet 4 in production? But you're thinking about it. So what about Puppet 3 in production? OK, great. Puppet 2.7? Puppet 2.7? Puppet 2.6? A little bit of shame coming out there. OK, how about the real shame? Anybody running 0.25 in production still? OK. You don't have to be too ashamed to say that. It's great that you're using Puppet. If you're on 2.6, 2.7, I highly encourage you to check out at least the Puppet 3 series. That was a really great release of Puppet and really set the stage for what we're doing the next couple of years. And of course, Puppet 4 just came out. I'm going to say a little bit about that later in the talk. Those of you not using or brand new to Puppet, I'm curious if you're using anything today, if it's another configuration management, if it's bash scripts, all that counts. I'm just curious, are you doing automation today in some form, but not Puppet? OK, a couple of you. All right, well, feel free to come talk to me about how Puppet might fit in there or how it might complement the existing stuff you're doing. Yeah, and hopefully if anyone's not doing automation, I'm sorry, it does get better from here, and no matter what automation choice you take, please take it. So I want to start this talk. It's going to be a general overview of what Puppet Labs offers, and I'm going to start with a little bit about why we're a company and why we're building software. So before I came to Puppet Labs, I came to Puppet Labs as a professional services engineer. And before that, I was a sysadmin at Penn State University. And I was doing production infrastructure for all the 40,000 faculty, students, and staff, the kind of file storage, user accounts, that kind of stuff. And the job is hard enough, as is. And that was several years ago when I was doing production infrastructure. And it's kind of a thankless job, and I was, for a while there, mixing desktop support with data centers. And it's constant interrupts, especially, how many of you are balancing production infrastructure with sort of IT, help desk kind of work, ticket work even? Are a couple of you out there? OK, so you're feeling some of the pain I felt. What I really, and I guess that's sort of what suited me to be a product manager today, it's highly interrupt driven. And so if you're being interrupted once an hour, it took me anyway, at least 30 minutes to get back to the task I was doing. So if I was building a new Puppet module for something, and I got interrupted to go fix a printer that went down, it took me a while to get back. It's a hard job. And it can be, well, I already covered that it's pretty thankless. I think you could probably empathize with that. But on the other side, I really love being a sysadmin. It's one of the few places where you can get a check for an immense amount of toys and play with those toys under the whole, oh, I'm doing work here. Yeah. But you really just get to play with all the new technology. That's, to me, one of the thrills of the job. Yeah, and I guess today, one of the big pressures you have to deal with is, and I consider this a good thing, but people have stopped considering IT a cost center that they just need to optimize, 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 and really neglect. I hope that's what you're experiencing in your organization. I started experiencing that at Penn State before I left, and I've seen that in numerous organizations as part of Puppet Labs. Now, that has some downsides when the CFO of the company stops thinking of you as a line item and starts thinking of you as a core competitive differentiator to all the other companies you're competing with. That means the spotlight's on you now, and you're being pushed to be more focused in your work, to be faster in putting it out, to help the development team reduce their time to produce whatever it is they're doing. That's the double-edged sword. But I think it's really great to see people treating operations and development as being critical to the business, not something to just cut costs on. And I kind of alluded to this. IT is becoming more critical than ever. Regardless of what you're doing, your business probably has some need to run servers. That's hopefully why you're here today. Whether that's just running the operations of the staff, the administrative staff of a department, if you're in healthcare or something, just providing all the infrastructure for the health staff, or if you're running some service on a cell phone. There's servers somewhere making that happen. And especially today, I think outages are less acceptable than ever. When I was at Penn State, it was a little bit awkward. Are any of you from academia? Anybody from an education institution? A couple of you? Okay. I wonder if you've had a situation where you can't touch production infrastructure until summer, and then you've got a month where you can make all your updates happen, and then throughout the year, you can never make updates, or if you do, it's maybe like Saturday at 6 a.m. or something like that, and even then, the faculty's really upset because they're getting their work done on the weekend. That was a really hard time. But it kind of shows you how critical it is to run that infrastructure. In my case, it was, we did a distributed SAN for the whole university with a bunch of different endpoints. You could get to it via SMB, you could get to it over NFS, we had a web gateway. And there's a lot of infrastructure, whether we wanted to update the storage, whether we wanted to update the network, whether we wanted to update those individual access points. It was extremely critical to the faculty, students, and staff, but we were not able to really do a whole lot to update it. Hence why I got into Puppet, to do automation so that I can make the best use of that 1 month window I had. And nowadays so Luke, our CEO who wrote Puppet, put it this way, that there's no future where there's fewer servers than there are today, and no future where there's fewer services than there are today. And that may mean there's a shell game at play. You may have less physical servers in your data center today. That might be just because you're condensing down to virtualization. It may be because you're moving some of your services to other providers. Maybe you've embraced one of the IaaS cloud providers. But the net total of servers on the planet is only going up. It's just a matter of who's running them and why they're running them. And in terms of services, that's only going up. Mobile phones should be the only evidence you ever need that every single one of those apps has a service somewhere, probably has multiple services providing that app, and there's hundreds of them, thousands of them, and all of them require infrastructure somewhere. So there's always going to be more servers, more services. They're more important than ever. And I've already touched on the competitive advantage part, and I hope you're all feeling that. And if you're not, come talk to me today. I'd love to hear about the company and the situation you're in. But I've seen a growing tide where everyone in operations, certainly everyone in development, though I think they've got that benefit a while ago, is more critical to the business than it was before. So I touched on you've got to be faster, you've got to be more focused, and this touches on a lot of different points. Faster means a lot of different things. Certainly in my world, so let's see, my infrastructure was a mix of Red Hat, AIX, Solaris, and Windows. And that was distributed, the AIX stuff was obviously on the IBM hardware, but we also had IBM Blade centers for a lot of our Red Hat infrastructure. And we had VMware on Dell running a lot of our other infrastructure, primarily the Windows infrastructure. And then we had a separate networking crew that would wire that all together or switch one of my blades onto a different port, or a different VLAN rather. And one aspect of being faster was just getting a new blade provisioned up, doing the service it needed to do. And that was not just my work, that was the network engineer's work, that was another sysadmin in my group. And every blade that I would go down, rack, put a CD in, get it on the network, get it booted, get it into the Kickstarter, all of that was a week just to get a blade. And I've heard horror stories where it's months to get a single, even a virtual machine up and into the network. Right? You start talking about security compliance. You can't put this on the network till it goes through all these scans, and you have to organize that with other humans in the building. That just isn't acceptable anymore. Is anybody taking more than a month now to get new infrastructure provisioned? Let's say new hardware on the network? More than a month? Is that killing you? Yeah. That's what I was feeling, and yeah. So we can talk a little bit about some of the technology Puppet Labs can help with, but I see that as just being one of the main factors of being faster and more focused. And it's also just getting new updates to, if you're running software as for part of your business, getting updates to the software rolled out is a big deal. So I used to be responsible for the Puppet Forge, which is our community for contributing modules. All the things you do with Puppet, you can contribute those to others. I'll talk about that in a little bit. But one of the aspects of the company that I'm focused on now is helping get application updates rolled out to the infrastructure. That's not just the core security and administration that Puppet is commonly used for. It's also the application stacks and the updates to the applications themselves. That's got to be faster. It's got to be more correct, and it's got to help with the uptime, not contribute to downtime. So focus is really just about doing one thing amazingly well. And so I'm going to touch on that in the cloud slide here. Cloud has become, well, it's become mainstream. I've seen television ads now for your own personal cloud, which is really just a hard drive with a Wi-Fi adapter on it. That's not cloud, right? It's not cloud, at least how I think about it. I don't think it's how you think about it. But it's certainly gone mainstream, where I talk to my mother about working at Puppet Labs, and she reads some article about moving into the cloud. She's like, "Oh, you're part of the cloud. I just got some of that." It's like, no, you didn't. You didn't get any of that, Mom. But I guess you're getting some of that with iCloud. So cloud. So one of the things that's been really interesting to me at Penn State, for instance, we didn't really have infrastructure as a service on top of our VMware stack. We were trying to get there. And that really, from the time I left Penn State to now, that has really started to mature and become a real option to supplement or replace an on-premise data center. Is anybody fully in AWS, Azure, Google Compute, any of the public IaaS? Nobody? Okay. I see that growing more and more, and it's kind of interesting to think about what those kind of things do. For instance, a lot of us run Vagrant and VMware Fusion on our laptops to spin up demo environments, to tinker around with Puppet modules. It's a really great workflow. But increasingly, especially for some of the work I'm doing now, I need hundreds of VMs, not a dozen of VMs. And so I use IaaS, primarily AWS, and that works out really well. I think that's going to be really interesting, and I'll talk a little bit about that more. But when it comes to that focus bit in the last slide, it's really software as a service that comes into play. So Penn State was kind of the antithesis of this. Everything a student needed, we provided on-premise. So their email, we provided, I think, a Dovecot IMAP service, some postfix for SMTP, and I think it wasn't Roundcube, it was Squirrel Mail as the web interface client. And we offered that to students, like, yeah, you've got your webmail. And they were like, this is terrible. I'm using Gmail, or I'm using some other service. I'm never going to use this. And faculty would freak out, because their students are supposed to be using the email service that they can control, and anytime there's an academic dispute, they're meant to be able to go and audit, have a third-party auditor look at the email exchanges between the faculty and student and resolve a dispute. That's not possible when Gmail owns the email. But it's kind of an example of where we weren't specializing in mail, even though we probably should have for that very purpose. We were treating it as a general service, and it wasn't meeting the needs of our customer, and they didn't want to deal with it anymore, so they started doing their own email. At Puppet Labs, I sort of have the opposite situation, where email is certainly not our business. If our ops people are spending their time building an email service for Puppet Labs employees, they're wasting their time. There's no benefit for our business to running our own email. Instead, our operations team spends time on our QA infrastructure, running all the virtual machines that test the software that we give to you. That's core to our business. That's where they're focused. And software as a service has enabled us to offload all the things that aren't core to our business. So our emails on Google Apps, our storage is on Box, and a sundry of other software as a service vendors. We have some for accelerating some of our graphical testing on, it's not Selenium, but it's whoever drives it. I think Sauce Labs. So it's things like that that are even on the fringe of what your core business is, but it's not infrastructure you have to run yourself that helps you focus on the infrastructure you run. That's a pretty big deal. And of course, containers. Docker has certainly taken the oxygen out of the room. They've, in the last year, become a really big deal, and I hope to have a couple conversations with you today on Docker. I know Nathan's been playing a lot with Docker lately. If you have questions, you want to talk to him. And it's an interesting kind of world. So I had, both on Solaris and AIX at Penn State, early containers, whether it was on LPARs or whether it was on actual zones. And I certainly played around with it a little bit, but that wasn't my core infrastructure. I was a Red Hat guy. So I never really got to get into it until now with Docker. And it's certainly interesting to think about. It's interesting to think about how that's going to reduce some of the thrash on systems, especially if you have a real configuration drift problem where you're not centrally managing everything and you've got different people touching the box and changing the configuration across a cluster. Having immutable infrastructure, whether that's read-only operating systems or all the way up to containers, it's an interesting idea that I think is going to change a lot about how we work and how we do operations. Certainly on applications, which I'm focused on a lot, Docker, that's where they're focused, on helping developers package their applications. You could think of it as a new age package management tool. It kind of is. And then think about how they ship those applications to production. Obviously, that area of Docker is not fleshed out yet. That's why it's not mainstream. But we're certainly looking at it and thinking about what are the operational characteristics of a Docker container. We can talk a little more about that. So just to drive home a couple of these points, we did this. Does anybody participate in the DevOps survey that we did last year or this year? A couple of you, thank you. So the results of that was just a whole bunch of people contributing to whether they consider themselves doing DevOps. And there's a whole lot of, first of all, let's discard DevOps as being a buzzword and think of it more as the cultural movement that it is. It's about operations aligning to the needs of the business, whether that's the CFO dragging you in or you're dragging the CFO in to stop thinking about you as a line item. And it's also working with the other teams in the company that are making the business successful. Commonly, that's the development team if you're running software, but it doesn't have to be. If your core business is an administrative team that does people's work all day and has no need for real computing, you still need to help them do their job. So they may come to say to you, I do this manual people shuffling around, and you realize you could solve that by a form that's backed by a database that you can query and run some tools on. That's your job, to work with that team to make that thing possible. That's a lot about what DevOps means. And when people start adapting certain practices like running their infrastructure and version control, doing deployments with configuration tools, you get more reliable results a lot more quickly. So we have some customer cases that we could talk more about today if you'd like. Getty Images, for instance, were a really big proponent of using Puppet Forge modules, contributing to those modules, and with Puppet code being able to make really broad changes of their infrastructure reliably, more quickly. Salesforce as well, Heartland. We have others on our website. If you want to learn more, you can come and talk to us today. But these are customers who have been using, whether it's for the infrastructure layer or the application layer, trying to achieve fast updates, consistent updates, and help other people do the business. So the rest of this talk is going to be an overview of how Puppet Labs can help with those kind of goals, and how our software is built to solve some of those goals. And I'm going to do it through the context of Puppet Enterprise, but I want to pause to point out that Puppet Enterprise and Puppet Open Source have a kind of a tight-knit relationship. We're not a company that builds sort of an open core and then just attach things on top and make you pay for kind of bells and whistles. We put our powerful software in the open source, and then we build workflows and kind of out-of-the-box tools to help you succeed as part of Puppet Enterprise. And the idea there being that if you have more time than money, but you want to do configuration management, you can put these pieces, the Lego bricks together, build really powerful workflows for you and your team, and succeed really quickly. And if you'd rather just get a jump start, Puppet Enterprise is there to help you with all the software out of the box, all the kind of commercial software I'm going to talk about that helps you get there faster, and of course the company standing behind you in terms of support, sales assistants. You have on-site with professional services. The people like me used to come on site to do training or to help you bootstrap your infrastructure. So keep that in mind, and feel free to ask me questions about it, but I'm going to be talking about Puppet Enterprise throughout the rest of this talk. But generically, what we're trying to do is just automation. Make rapid changes, regardless of what kind of infrastructure you're making changes to, make it reliably, and make it auditable. It's a really key characteristic to be able to understand what change has been made across the network. That was one of my biggest frustrations at Penn State, where we had, it's actually a pretty big IT team. It ended up being 20 sysadmins, which maybe, given the scope of 40,000 faculty, students, and staff, isn't that large. But there was a lot of cooks in the kitchen, a lot of people making manual changes. And we had a lot of die-hard Solaris admins that would log in with all their X Windows sessions, and they would do different things on different boxes. Sometimes it would be great. They were really smart people. It's not like they were bad sysadmins, but humans make mistakes, and they make them randomly, and that caused a lot of problems. So when it comes to what we can automate with Puppet, it's really anything that you can think of automating, though between out of the box and the Puppet Forge, everything on this list and more. And that regarding the operating systems, Puppet Labs is very heterogeneous. Anything you want to touch, whether that's Linux, Unix, and Windows. Yes, Windows, we can do that. And then whether it's any cloud provider, there's a couple nuances to that. I'm going to talk to you a little bit about how we can help you get infrastructure running on a public cloud. But we've also built in a bunch of tools to say, let's say you're running VMware, and you need to get VMware tools on all your guests, and you're not using the VMware auto-install business. You can use Puppet to install the VMware tools on all the machines. It's got a tool inside called Factor, which identifies what it's running on. And then it can say, yep, I'm on VMware. And you can tell Puppet, when you see a machine running VMware that doesn't have VMware tools installed, install VMware tools. Network and storage is a new space for us. If you go to the Forge and search for F5, for example, you'll see some of our early work to help you automate F5 network devices. Juniper, Arista, NetApp. NetApp for storage is a new one for us, and of course Cisco. Some of these you'll find run a Puppet agent on the switch itself or on the network device. Some of them remote proxy, but both are first-class citizens as far as we're concerned. We'll help you get there. That would have been really interesting for me, although I don't know if I could get it done. I worked closely with one of the networking guys to get all of my infrastructure at Penn State loaded. And it was, he was a busy, busy guy. And he was also responsible for the Shibboleth identity infrastructure. We could have really used some automation just for simple things like switching a machine between VLANs, say between the provisioning network and the production network, or between the production network and the development network. Simple tasks, automate them. And of course, applications, whether that's you want to run your CI infrastructure and manage that with Puppet, whether you're running your application stack, or whether it's just infrastructure like Splunk or Logstash, if you want a whole ELK cluster, all of that kind of stuff you can do out of the box with Puppet and the Puppet Forge. So our approach is about defining the desired state of your infrastructure. We're not a scripting engine. We don't take your scripts and run them in order. We're asking you to pre-model what it is you want a machine to look like. And you do that in sort of building blocks as little or as big as you'd like. We try to encourage you to keep the blocks small. In other words, let's say you're building that ELK cluster, and you've got Elasticsearch, Logstash, and Kibana. With Puppet code, you can separate those three services out into different sets, and then combine them however you like. Maybe some team just wants Elasticsearch, and you can just produce that. They're using something else to get data into it. You can combine that with Logstash, or you can attach Kibana on top. The idea is that you're describing all of these things in code and then putting them together how you like. In this example, we're managing just a common primitive, the service. In this case, SSH, ensure that it's running, enable true, so it comes up on boot. And you just describe it in the state you want. It's not about actions. Puppet worries about the actions. It knows how to inspect the state of that service, determine whether it's running or not, and it knows how to correct the state if it's not running. When it comes to all the different operating systems, service stretches across all the different operating systems, so you don't have to use a different language for different operating systems. But of course, some properties change. SSH isn't the name of the service on every OS. In fact, I don't think it's the name of the service on any OS. And there's a lot of built-in language features to help you abstract that away. So you can say, hey, my SSH service should be running, and this is what the name of that service is on all the operating systems I manage. So the idea is once you've defined your infrastructure as code, you want to test the change that you're going to make to your infrastructure before you deploy it. It's about reducing the downtime, being confident about the change you're rolling out, and can be a bargaining chip for you to roll that out during a maintenance window that's sane instead of 6 a.m. on a Saturday. And there's a few different aspects to testing, and I think somebody's given a talk today. Nathan's given a talk on testing Puppet at 4 o'clock, and he can tell you about a lot of the different aspects. But one of the core aspects of Puppet for doing testing is something we call no-op, or simulation. So I described how a service, Puppet knows how to inspect whether that service is running or not. So if you tell it service should be running, it should be enabled on boot, what you can do is say, hey Puppet, I want you to go and make all the machines running SSH right now, but do it in no-op mode. And what Puppet will do is go to each of those machines, it'll take the state that you told it to make, and it'll compare it to what is running on the machines. It'll inspect the service, SSH, on all your machines. And then it'll come back and tell you, on this machine here, I found service SSHD or SSH stopped, and it should be running, and this is what I would have done to make it running. But it doesn't take any action. That's one aspect of testing a change before you deploy it. And there's others as well. You can get as crazy as you want. You can go all the way into development level testing where you're writing RSpec unit tests for your code and making sure that it all matches every time somebody makes a change. But the core essential of just saying, look, this thing I'm telling you to deploy, tell me what's going to happen before it happens, is a critical aspect of Puppet and something that most people run every single time. So naturally, once you've decided you do want to roll out that change, you enforce the change. And that's Puppet's default run mode. In this case, we're managing a file, and you're just saying the content should be one word. The Puppet gives you a lot of facilities for delivering files statically. It can build files dynamically based on information on the host or other information you give it. And it can serve files from other endpoints. But in this case, you're just saying, here's my file. I'd like it to be there, and I'd like its content to be this one word. Puppet will ensure that that state exists on the node. Everything that Puppet does, even in that simulation mode, it'll report on it. And so Puppet Enterprise here gives you a graphical console for viewing what changes are occurring across the fleet and how those changes went. And we categorize that by changed, which is the one where you say, hey, SSH should be running, but it's not, and Puppet corrects it. It'll say it was changed. If you're just doing an enforcement run, or sorry, a simulation run, it'll tell you, hey, Puppet was going to change the service. Here's what it would have done. That's listed as a pending change. Commonly, what I see is people roll out new Puppet code updates throughout the week, and they'll run Puppet in the background in its no-op mode. And so Puppet will constantly be pushing reports to the central console saying, here's all the pending updates. And then the team on Friday, Thursday, whatever your day is, they'll review the change, approve all the changes, maybe reject some, and push that Puppet code out of the Git branch or whatever. And then they'll go and run Puppet in enforcement mode everywhere to deploy the pending updates. So you can kind of batch them together, but with an understanding of what will happen when you press the big green button. So everything you do, it's very detailed. You can see summaries and all the details of exactly what commands Puppet took on systems, whatever you like. So I'm going to show you a couple more pieces of code before I get into the rest of the technology. This is a more elaborate example of a file. In this case, we're telling Puppet the path of the file, ensure that it is a file. In that case, Puppet can ensure things are files, directories, symlinks, owner, and mode. And this will work across Windows too. Obviously, the details change. But the idea is you give it the ownership it needs, the permissions it needs, and source is telling Puppet, in this case, don't make it this one word. I want you to serve this from the Puppet server. And this is a static file for SSH deconfig. And then there's another option here where you could swap out that source line for, say, a template that builds dynamically. And then this last bit here is a critical piece to Puppet's language, this require. So the whole point is that you're modeling how your infrastructure should work. And in a lot of cases, you've got dependencies between individual things. The classic pattern is the package file service. You need a package installed before you've got a service to manage, and you probably need to tweak that configuration file for that service before you start the service. So with Puppet, you can state a requirement like this. This is a simple one where you're saying, I have a file, and then in require here, you reference somewhere else this package resource that you've already written. And that tells Puppet, I'm never going to touch this file until I've managed that package, until that package is in the state you want. This is a little more complex where you're managing the file, package, and service, that common pattern. And in this case, we have a requirement between the different packages. And we could take this a step further, and on the file, you could say whenever the file changes, you can tell Puppet what's called notify from this side to this side, or subscribe, in this case, from this side to the file. So you say, service SSH, subscribe to that file. And Puppet does the same thing it does for every other resource type. It knows how to inspect the content of the file. In this particular case, because we're serving a static file, it's doing an MD5 checksum of the two files to know that they're different or not. You can use things like Augeus to do individual pieces of the file to know when they differ. In this case, it's pretty blunt, but it knows when the file's different, knows when it would make a change, can simulate all that for you, tell you which MD5 sum it would be and was. And with that subscribe, it knows that whenever the file does change, the service needs to be restarted. And you have some controls to say, for instance, in Apache, you can tell it to do a CTL reload instead of restarting the whole daemon. I've got a Windows example here for you. Is anybody managing Windows today? Okay, a few of you. There's a whole lot of primitives in Puppet today that work out of the box on Windows. And then on the Forge, you can find new resource types for other parts of Windows, in this case, IIS, and the sites, virtual applications, and app pools, and I think a few other resources. And the ideas are all the same. You write out the state you want. You can fill in data dynamically if you'd like. You can create relationships between these things so that they're managed one before the other. You can have them react to changes in the others. But it's all just code that you can save in version control, that you can review with your peers. And it's complex as it is. At that point, you're just managing a code base, and it's as little or as much code as you want. And a lot of it comes out of the box, and a lot of it comes from the Puppet Forge. And of course, you can write your own. It's very easy to do. So let's get into what Puppet Enterprise offers. This middle box there, the open source components, I'm not going to have a slide on each of them, but they're Puppet itself. There's Factor, the inventory tool, and that thing knows what operating system am I running? Am I virtual? What's my BIOS ID? Things like that. There's also things for data called Huayra. It's all about data. And there's a whole bunch of other tools on the platform side, on the open source side. And then above that is where I'm talking about those workflow tools. So Puppet Enterprise primarily offers you applications that build a workflow for using Puppet to enforce configuration change. So node management we're going to get into, as well as configuration management. Those are pretty self-explanatory. Code management is something we just released with Puppet Enterprise 3.8, with R10K being the open source component in that Puppet app. And the whole idea there is that you've written all this Puppet code. You need some tools to help you manage it so that you don't have to do all that yourself. So that's as simple as, I'm storing it all in version control, and I want to map my version control repositories to my Puppet server. I don't want to do that manually. R10K helps with that. And then code management is going to start adding, as future PE releases go on, workflows around testing your Puppet code. So you don't have to stand up your own CI and all the hooks to test your code as you make changes to it. That'll be stood up for you by Puppet Enterprise. Things of that nature go into code management. And then application management is my specialty. It's what I'm working on now, and I'd love to talk to you about it later today. But that's sort of how does Puppet help you build the application infrastructure, deploy updates to your applications, and help you deal with all the different cross-node dependencies that you may have. For instance, a database server needs to be up before my API service can speak to it. Those kind of problems. OK, so before we get into the individual details, the core life cycle of a machine is laid out here. Again, across any operating system, it doesn't matter. Puppet treats it as the same. And the idea is the first thing that happens is a server sends its fax, and that's using the Factor open source tool, and it has, I think, 100 and some and all these different extensions. You can write your own fax. Basically, anything that you can query on the system with a shell command, with an API, by reading a file, by reading proc, any of those things, Factor can return as key value pairs. And so it sends all of those to the Puppet server. Those might just be for the inventory dashboard in Puppet Enterprise, so you can view the inventory of your whole fleet. Or you could use that to change the configuration dynamically. For instance, if the memory bumps up, you may want to change how much memory is allocated to your JVM. That can be done using Factor. Anyway, it sends all of its facts. Puppet server uses all the modules you've written, all that Puppet code you've written or downloaded from the Puppet Forge, and it builds what's called a catalog. The key point there is that the catalog is the exclusive set of instructions given to that node. So you're going to write Puppet code that is all the possibilities on your data center. And it might be the database model for your whole infrastructure, and the piece that changes is your database password. Well, each of these nodes that are participating in your DB, they don't get the passwords for all of your infrastructure. They just get the one that belongs to them. That's what's in the catalog. That's what separates all the possibilities from the individual instructions that Puppets do either simulate or enforce. Once Puppet does simulate or enforce configuration change found in the catalog, it sends a report back to the Puppet server. And we're going to talk about how that report's used, but it's pretty flexible. That report can send you an email, it can store it on a log, it can put it in a web browser. But before you do any of this, you need infrastructure. So one of the things Puppet Enterprise offers is Razor, which is all about bare metal provisioning. So Razor is, it's got a lot of the kind of things you might expect from Puppet if you're using it today, the kind of dynamic inventory. The idea is you take your Dell hardware, you rack it, you put it on a provisioning network that has Pixie on it, and then what happens is the server comes up, talks to the Pixie server. The Pixie server deploys what we call a microkernel, and it's just a micro version of Linux running mcollective and factor. And what happens there is this machine has all of its facts, which you can see in the bottom, number 2. And in this case, the important facts are how many processors do I have, how's my memory, and you can get things like MAC address, all the interfaces, all the details that you might make decisions on. You know, if you've got a rule, a business logic rule that says machines with a ton of NICs and a ton of disk are my database servers, then you can describe that in a rule-based engine, number 3 there. And Puppet can be told to provision an operating system and all the configuration that goes with it based on those rules. And so the workflow is essentially you boot the machine up on a Pixie network, on a provisioning network. It gathers information about that hardware. Maybe that just goes into a pool and you make manual decisions on your available hardware pool. So you might spend a day racking your data center, let it all boot up, and then go into Puppet and say, OK, this is what I've got. This is what's live. This is what somebody needs to go and check the NIC on this box because it never came up, that kind of stuff. And then you could say, all right, based on the hardware information I have, go and provision. And Puppet will then create that operating system image. So whether it's Linux, Windows, whether you want to build up a ESXi server, it'll deploy that, boot it into Puppet, connect it to your Puppet server. It'll get the configuration that you've assigned to it, and it'll configure itself. And oftentimes, one of the configuration steps will be to switch VLANs. So let's say you're using F5 network devices. You're using the Puppet module for F5. You can instruct Puppet to switch it to a production or development VLAN off of your provisioning VLAN. So that's bare metal. When it comes into virtual machines, we have stuff built into Puppet Enterprise for VMware to help you build VM instances, and we're soon going to release something that lets you describe it as code. But I don't have slides for that. I'm going to cover Amazon now. And this is a fully loaded EC2 instance. One of the other features of the Puppet language is that you don't have to describe all of these things on the left, the blue words, which we call parameters. These often have defaults. But in this case, it's fully loaded, and you're describing in code the name of your instance in EC2, which region it goes in, availability zones, the image, the whole thing. And Puppet will do the same thing it always does. It'll query EC2, identify whether that instance exists. If it doesn't exist, it'll build it. If it's running the wrong resource type or the wrong CPU or whatever, it'll change it. All that kind of stuff. But where it gets super interesting to start managing Amazon resources is not just the instances, but all the things that go around your instances. So in Puppet code, you could describe the security group that a machine or machines belong to. You could describe a load balancer. You can start to see how an entire stack can come up. A fully load balanced stack, it can be described in Puppet code, can be reviewed with your team, can be tested for deficiencies, and can be deployed with Puppet in simulation and enforcement mode. Same thing goes for some more esoteric things. So you can do auto-scaling groups, which I guess isn't that also, and launch configurations as well. And actually, I have a new slide here for the DNS. So if you're using Route 53 for DNS in EC2, you can manage those records as Puppet code as well. So you're going to see this coming out for other cloud providers down the line. This is available on the Puppet Forge today. You can just search for AWS and use this. We're going to have similar descriptions for VMware, though today there's a command line tool built into Puppet Enterprise that'll help you build VMs on VMware. And there's modules in the Forge for building a vCenter and all the surrounding infrastructure. So it's just the DSL descriptions that we're building today. And you can even go, I mentioned earlier, you can go as crazy as you want on the testing side. In this example, we're doing unit tests for your EC2 infrastructure. So you can run rake spec and determine whether all the infrastructure that you've told Puppet to build actually matches what you've built here. The idea is you've got Puppet code describing the different instances, and you know in your test that you should always be in a certain region, like say US West 1. So let's say somebody edits the Puppet code someday, fat fingers it. So it's not US West 1, it's US Westeros, right? Something like that. This kind of a test would catch that before it goes in, and Puppet tries to enforce a machine in a zone that doesn't exist. You don't have to do that, but that's something you can do. So you can also manage Docker with Puppet. Now we're experimenting internally with what it means to be a Docker container in a Puppet managed world. Puppet usually has a bunch of software running as daemons on your machine to manage it. They're lightweight services, but they're still services that are running. Docker containers are meant to be immutable, so you don't want that daemon on there, changing configuration and deploying it. So we're still working on what is the workflow, or what can we do to push it so that you're doing builds with your desired configuration of those containers. But on the Forge today, you can download our Docker module and stand up an entire Docker installation to play around with it. You can download images from any Docker hub, yours or the public one, and you can run containers in Puppet code. So you can use the same tool chain you're using with Puppet to experiment with the future of immutable infrastructure, see how you like it. I've got to get a little bit faster here, but we've got this Puppet server, which is sort of the heart of everything. Those of you who've been using Puppet for a while may have been used to running Puppet as a Ruby process behind a passenger server or Mongrel or something like that with Nginx in front of it. So one of the things we needed to do to get Puppet to the next level was build the internals so that it's still a Ruby piece of software, the open source Ruby software, but it's running under JRuby in a JVM container. We did this early on with PuppetDB, the inventory data warehouse. It has all your facts, all your reports, all the catalogs that were enforced. It stores all of that. That was our first closure-based service running on the JVM. Really high performance, really easy to tune, good operational characteristics. If any of you are running JVM applications today, they can be horrible, but they can be lovely. So a Puppet server is the next generation way to run the Puppet master. PuppetDB, I mentioned earlier, is the central data warehouse for all your Puppet infrastructure. It has a rich API and a number of plugins to that API. So you can ask questions like, how many of my machines running this particular operating system version have this package? And it'll tell you when the last time Puppet ran to enforce that package and what version that package was at. That's kind of a complement to live discovery. You can determine back in history where your machines were at with PuppetDB. That's also a closure-based service running on the JVM. In Puppet Enterprise, we have what's called the node manager, which you may have seen on a previous slide. The idea here is that in Puppet code, you've written all the possibilities, the model of what's possible. You still need to tell machines exactly what they're to do. And the whole idea is it should be tunable. Your development infrastructure looks different than your production infrastructure. It might just be things like database passwords. It might be that you collapse the whole stack onto one machine in development, and the production infrastructure is stretched out to 3 different machines. The model makes all of those things possible without repeating yourself. You don't have to write another line of Puppet code. You simply have to do this act we call classification, where you pick a class that you've written, say the Apache web server, and you're telling it, here's the port that I want you to bind to. Here's the different virtual hosts I want you to build. This node manager gives you a rule-based way to do that. So the information coming in about what operating system you're running, what NICs you have, what's your MAC address, all kinds of stuff, including custom ones you write yourself, you can use to make decisions about what configuration gets applied. Coming with that is role-based access control, and this is really common when you've got big teams managing infrastructure. You've got a core set of people who are writing all the Puppet code, setting all the possibilities, but you've got people who might just be racking hardware, provisioning VMs, and they just need to be able to assign particular classes to those hosts. The role-based access part of the node manager gives you the control to say, these people can control everything on these hosts, or you can do it a different way and say, these people can apply these parts of Puppet to whatever sets of infrastructure they have control of. And you can integrate that with your existing AD or LDAP. So we've got Huayra, and this is where so you can use the node manager to kind of fill in configuration details in a rule-based way on the graphical console, which is really great for delegation. If you're dealing with high volumes of that data, the parameters that you need to apply and the different data, and you want to store them as files on disk, that's where Huayra comes in. So it's similarly rule-based. Huayra means hierarchical, so you create a hierarchy of data lookups based on the rules you care about. And that might be things like location first. So you might determine which data center is this, and then there's different data associated with that. Commonly, you would say, this data center in the West Coast binds to this NTP server on the West Coast. And then any machine that comes in on the East Coast goes to a different time server. Those kind of things you would build out either in the node manager or in Huayra. And then if you're using Huayra, it's all just files on disk, and it's extensible. You can do YAML or JSON out of the box, and there's other plugins if you want to store your data in a different way. And then the Puppet server just uses that as part of its instructions when it builds that catalog. Speaking of modules, we do have a number out of the box, like I said. There's over 3,000 on the Puppet Forge. And we're starting to curate sets of that content on the Puppet Forge that kind of have the company's approval behind it. So Puppet Approved is a newer program that has about 50 or so modules now. These are community-written modules that Puppet Labs employees have reviewed, audited, maybe contributed some code to, and put a stamp of approval. There's a criteria list on the website that you can review, but it's sort of just best practices from our professional services teams, our engineering teams, and we reviewed modules to make sure they meet that, to make sure they meet our security concerns, and then we approve them. So you can kind of have a level of confidence when you use those modules. And then we also offer supported modules, which are, so far, modules written by Puppet Labs employees with commercial support behind them. Often that's commercial support from our support team, but in the case of some of our network devices that are also supported, it may be a bidirectional relationship between the network vendor and us, or just the network vendor, so that you can call and ask questions about how to use that module to manage whatever it is you like to manage. Especially on the Windows side, we just released a module for Microsoft SQL Server, so you can manage the SQL Server instances, databases on them, the grants, the users, all that kind of stuff. I mentioned F5, but on the Windows, we also have a lot of other stuff like managing access control lists, PowerShell. That's not something you get when you download the Puppet agent. We keep that thin and light, but it's something you download from the Puppet Forge, and it's just one command with either R10K or the built-in Puppet module tool to install this functionality onto your Puppet master. Speaking of R10K, I talked about that code manager Puppet app. The idea here is that R10K can collect all of the modules you wish to deploy. And that might be, depending on how you segregate it, all the modules belonging to your infrastructure, all the modules belonging to the infrastructure in a particular environment, production development, whatever, or all the modules for a particular application if you want to segregate it out so that certain teams have this Puppet code and other teams have this Puppet code. R10K gives you a simple format for describing that. But its core feature is this: mapping branches you have in Git. Who's using Git in here for version control for whatever purpose? I don't necessarily care what. Great. And if you're not, there's a lot of tools out there to help you, including a course from Puppet Labs on using R10K with Git, with branches, with environments. It's a really powerful concept because you can take, in this case, let's say you have a Puppet module that you're making a change to, and you want to evaluate that change before you roll it out to production. Maybe it's a really big change that you're not that confident about. R10K makes it easy to take that module, Git branch it, and then tell Puppet, OK, take this Git branch and put it on my Puppet server in an isolated place called a Puppet environment. So it'll map that Git branch, feature A to feature A, and that's just immediately available for use on your Puppet master. Then you could take a machine, one of your canaries or one of your workstation machines, and run Puppet against that environment. So you can tell Puppet, hey, go evaluate the changes available in the feature A environment. And it'll enforce Apache with that module change you've made, and you've never had to do any kind of gymnastics. All you've done is push a Git branch to your server that the Puppet master can talk to. It's a very powerful workflow. There's another visual representation of that. Take an individual module or all of your modules. You can make changes to them in forms of Git branches. You can evaluate all of those changes in different Puppet environments that don't impact your production fleet. And then as you merge branch changes upwards, so let's say you've took that change, you've approved it, you just merge that into your production branch, and you're ready to deploy it. R10K does all the busy work for you. So we also have Event Inspection here, which is all the reporting tools available for Puppet Enterprise. This is where you can go in and view those unresponsive nodes, the nodes that have pending changes, and so on. But you can also look at the operational characteristics of the Puppet server and all of its services itself. So you may have seen this at PuppetConf last year. This is our dashboard for metrics on how long is the Puppet server spending, building catalogs, how long are requests taking. It can help you understand when you need to grow your Puppet infrastructure and when you need to kind of tune it and understand what you're doing with it. So we've also got mCollective for remote execution. And think of this as a complement to Puppet. Puppet is about configuring, describing a state you want to have configured, and then having Puppet simulate and enforce that change. mCollective sits outside of that and says, I want to take an action on an infrastructure. Maybe you build a workflow around it to deploy your application. mCollective says, OK, I'll touch this machine, do some stuff, touch this machine, do some stuff, touch this machine, do some stuff. And maybe part of that stuff is running Puppet to enforce new configuration. But it's sort of this thing that sits above in a fabric. It can also just be used for simple inventorying. One of the most popular uses of mCollective is just to ask questions of your network. You say, what machines are responding right now that match certain criteria, different operating systems, different facts, whatever, anything you have available in Factor, and it'll do real-time polling and real-time response of all of that in an asynchronous way. It's not a very serial process. It'll just pull all the machines on the network. It's very quick. So I mentioned open source Puppet earlier. We just had a 4.0 release. And there's a couple interesting things about the 4.0 release. The one is this file system layout, which we call the all-in-one agent. Previously, you had to install all the open source packages together, or separately, rather. So you had Factor, Puppet, mCollective, Huayra, all these different tools, whether you need it on the server or the client side. A lot of packages to put together. We also had Ruby, which we offered on Puppet Enterprise as a vendored Ruby, so it either didn't conflict or you didn't have to bother with it. We've combined all of that so that you have one unified Puppet-agent, which has all the necessary software needed to run the Puppet agent, regardless of whether you're using open source Puppet or Puppet Enterprise. The agent's exactly the same, obviously version differences notwithstanding. And you can switch between Puppet open source and Puppet Enterprise infrastructure as you wish. The server is then separated from the agent, essentially. So I'm going to go into this language enhancement bit. Here's an example of how people did iteration before in the top example. And that was what we call define types, where you could kind of create this model of a thing that you would instantiate out. And people would use that to iterate over data and build a particular, I guess, a notice in this case. So we've added proper iteration support. And this is simple stuff. It's not full-blown programming language. Puppet's still a simple language for sysadmins. But we're giving you easy ways of combining different data types together and, yeah, iterating over them. So we've also rewritten our parser and evaluator. This is the guts of how Puppet takes the code you've written and turns it into instructions. It's now way faster. And when there are errors, it doesn't just say, I had an error at this line somewhere, and it's actually the line above it. It'll actually tell you the exact line, the exact character, and usually it returns you the exact problem and suggests a solution. It's way easier to troubleshoot Puppet. We have this catalog preview tool in Puppet Enterprise. If you're looking to move from Puppet 3 to Puppet 4, we've got this tool that will take your Puppet environments, compile catalogs for all the machines in those environments, compare them, and tell you where they might differ. And that's usually just compatibility issues in the language. For instance, we treat numbers as actual numbers now, as integers, not just strings. And so that can have odd behavior depending on how you use numbers in your Puppet code. So the catalog preview tool will tell you when those inconsistencies might impact the configuration of your nodes so that you can make those kind of adjustments before you roll out Puppet 4. We've seen this used so far to make upgrades from 3 to 4 really easy, really error-free. Feel free to come talk to us about that. I'm pretty excited about it. I'm going to skip over optional types, but this is where we are. You can actually say, this thing needs to be an array, this thing needs to be a string, stuff like that. I've talked about iteration, simple syntax for iterating over values, filtering them out, reducing them down, simple constructs. I'm happy to talk more about that after. So I'm going to skip through some of these slides. This one is just trying to drive home the DevOps survey results. If you want to go and dig into the whole DevOps report, it's a free report. You can just search for the State of DevOps report. We have one coming out for the 2015 survey that we just completed. And after Puppet Camp, if you're looking to go and take action on this, after you've watched all the talks today, there's a few things I'd like you to leave with. One is puppetlabs.com/learn. So this is sort of a hub for finding courses you can take in your area with a live instructor. And these are sysadmins who have been using Puppet forever and come to talk to you about their Puppet experience. We've also got online self-paced learning, so you can go learn the basics of Puppet, learn the basics of writing Puppet code, just online for free, just kind of take a quiz, write some code, do that kind of stuff. We'll even give you virtual machines to use online. We also have the docs, docs.puppetlabs.com. This is a good entry point if you like reading documentation. We've got a really great docs team who have created really a mountain of stuff that's really well written and easy to read. I just talked about our training. There's 3 levels here. If you're brand new to Puppet and you just want to bootstrap yourself really quickly, the fundamentals course, it's 3 days on site. I used to teach this every day. It's a really good course for just getting the basics down and getting out fast. You could take this 3-day and skip a month or 2 of just learning on the spare time kind of thing. And you get access to a professional labs, professional services engineer. The practitioner course is the next level up. If you've been using Puppet for a while and just want to kind of advance yourself on all the supporting tools, that and the architect course are there to help. I talked about the Puppet Forge. Make sure you go there and check it out. This is really a central part of using Puppet now. It used to be a very small community. Now it's got over 900 individual authors, thousands of contributors on top of that, a lot of Puppet code that has been reviewed by Puppet Labs, supported by Puppet Labs in some cases, and the community stuff is really great. There's a lot of stuff there now. The Puppet Test Pilot program is really important to me. When we're working on things that are brand new and we want some feedback from you, this is a structured way to get an email on a list saying, here's this thing we're working on, does it interest you? You can delete that email, or if you're interested, you can reply, and you get to talk with our user experience people. It's not a marketing exercise. And for your time, we usually offer shirts, gift cards, stuff like that, just to get your feedback. You can contribute thoughts on how you'd like the Puppet Labs to go further. You usually have somebody from product in the room with you. It's a really great program, puppetlabs.com/PTP. We also have the community site, which gives you a lot of different resources, like the mailing list. There's the Ask site, which is sort of a Stack Exchange style question and answer site. And there's a lot of other options there, including our IRC channel, which is still one of the biggest channels on Freenode. It's #Puppet. Andrea mentioned earlier that she's here to talk to you about jobs. If you're looking to join Puppet Labs, you can check out the website or go talk to Andrea in person. I highly recommend the latter. We do have offices all over the planet now. Of course, we're headquartered in Portland, Oregon, but we have an office in Belfast, Ireland, Northern Ireland, and London as well. And then, of course, all these dots around the world. We have people everywhere, including Australia. And of course, finally, PuppetConf. Come join us in Portland this year, our hometown. It's going to be a lovely conference. I'm really excited about it. How many of you went to PuppetConf in the last 2 years, the San Francisco PuppetConfs? Okay. I hope you had fun. I hope you come this year. It's a really great show. I'm certainly really looking forward to it. I don't think we have any time for questions, but I'm here all day, and incidentally here tomorrow. So I'm Ryan at puppetlabs.com, and I'm Ryan Y. Coleman on Twitter. You're also welcome to post questions to the #PoundPuppetCamp hashtag, and I'll answer them for you after this talk. Sorry I didn't have time for it, but thank you all, and I hope you enjoy the rest of the talks.